Sorry for that interruption, guys. Okay, so let's take a look at this. We see that there is a repeat. We count up, when we count the portrait type of paintings, we know that we've counted the three that are already the oil paintings. So when we count the portrait and the oil paintings, we're counting three twice. So we need to get rid of this 3 out of 30. Are you guys with me? And then we end up with 13 out of 30. 6 plus 10 minus 3 gives us 13. Denominators the same. All right, let's go on to the next examples. As we mentioned before, the idea of complement is the fact that you know that there is a probability for event A to happen. The probability of event A not happening would be 1 minus the probability of A. In example 4, we have complementary events. Let's consider this. Francesca bought 20 raffle tickets hoping to win the $100 gift card to her favorite clothing store. If a total of 300 raffle tickets were sold, what is the probability that Francesca will not win the gift card? So first, let's figure out the probability of the win. The probability of the win is 20 out of 300. Because she bought 20 raffle tickets, there's 300. We're assuming that they're just putting them all in a bag or something and drawing out a name. And so we can reduce this to recognize that her chances of winning are basically 1 out of 15. However, what we really want to know is her chances of not winning. And clearly this is a situation where we're talking about the complement. So we're going to calculate or figure out what is 1 minus the probability of winning. And I know you guys probably did that 10 minutes ago, but that's going to be 14/15. So she has 14/15 of a chance of not winning the, what is it she's looking for? The $100 gift certificate. I wanted to draw your attention to page 960 in your text that has really nicely laid out a way of considering what is the best probabilistic model to use. So I want you to consider using this to study and prepare for your assessment, and it's on page 960. Our final example required a little bit of additional information, so you see I've written it in here. 81% of American motorists wear seatbelts, and this is going to be another situation where we need to consider, well, we really need to consider what are we looking for and how best to find it, what's the easiest way. So we're going to refer to the information down here that 81% of American motorists wear a seatbelt. Suppose two people are chosen at random from a group of 100 American motorists and passengers. If this group mirrors the population, what that means right there is that if it mirrors the population, then about 81%, therefore 81 out of 100 people will prefer to wear a seatbelt, okay? So if this group mirrors the population, what is the probability that at least one of them does not wear a seatbelt? So it's kind of a weird thing to think about, but we're choosing two people. And so if we think about what this circumstance looks like, we have these two people that are chosen at random, and there's only really 4 different situations that can happen. So either that first person loves to wear her seatbelt and the second person also loves to wear his seatbelt, and that's great. Or that first person loves to wear her seatbelt and the second person chooses not to. Or the first person doesn't like to wear a seatbelt and the second person chooses to wear their seatbelt. By the way, these red and green marks are seatbelts. Or both of them choose not to wear their seatbelt. So these are 4 different scenarios. So let's legitimately classify them as 4 different scenarios, A, B, C, and D. And so what I want to do for us is really consider, well, what does it mean for scenario A to happen? And what does it mean for scenario B, scenario C, and D in reference to our question? What is the probability that at least one of them doesn't wear a seatbelt? What this question is really asking is, what's the probability of B, C, and D? They're not asking about A. But if we found the probability of A, we can use the complement situation and then find the probability of B, C, D without having to calculate the probability of B, the probability of C, and the probability of D. Does that make sense? So we're going to do that here right now. So the probability of scenario A will be calculated similar to the way that we calculate anything. So, if we are choosing two people at random, the first person we choose, the probability of them wearing a seatbelt will be 81 out of 100. There's 81 out of 100 people that we could choose for that particular position. Let me write this a little bit lower. So 81 out of 100, right? And then for the second person, now we still want to choose a person who's going to wear their seatbelt. That would be 80 out of 99. And so this would be the probability. Let's calculate it real quickly. Cross cancel will help us out immensely. And this will become 9 goes into that 9 times 9 goes into this 11. So we have 36/55. Okay, so this is the probability of scenario A, but what we really want is the probability of the complement. Let's get rid of this and we'll figure it out. So the probability of the complement, you remember how to do it, will be 1 minus the probability of the happening. So I could write that the probability of scenario B, C, and D happening is 1 minus the probability of scenario A. And so this should work out really straightforwardly. 1 minus the probability, which is 36/55. And therefore, you know that the probability of one of these people not wearing their seatbelt will be something like 19/55. All right. And that's it for this lesson, and that's it for the lessons, the new information that will be coming your way. So we're going to work on preparing for this assessment and preparing for our final end of year exam. All right, guys, let me know if you have any questions or concerns. I look forward to talking to you all soon. Bye-bye.